Alright, so 41, we can easily do it with synthetic division and do it in a fraction of the time. But I'm going to go ahead and do long division just to give you the practice or the review of long division. So we put the x plus 2 out here. Make sure the dividend is in standard form. It is, so x to the fourth. Oops, that's a 3. Okay, so then x times what gives you x to the fourth? That would be x to the third. And then you multiply x to the third by the divisor, so that gives you x to the fourth plus 2x cubed. Oops. Now we subtract. So when you subtract, you add the opposite, so that's a negative right there. And so this is gone, and so 7 minus 2 is 5. Bring down the 10, x squared. And then x times what gives you 5x cubed? That would be 5x positive 5x squared. So that's 5x cubed plus 10x squared. We're going to subtract by adding the opposite. Okay, and so now I have 0, right? So then I bring down the next two terms because I don't have any left here, so I bring down negative x minus 2. And then something times x times something gives you negative x, so that would be negative 1. So negative x minus 2. And then you add the opposite, and you get 0. The remainder is 0. So the answer is x to the third plus 5x squared minus 1. That's the quotient. So 42, we're going to use synthetic division. So we're dividing by x minus 4, which is x minus a, so a is positive 4. So here I put the 4 inside the little backwards L. Make sure that the dividend is in standard form, so the first term is 5x cubed, right? So I put a 5. Then the negative 18x squared, so I put a negative 18. Then the negative 11x, so I put a negative 11. And then the 12. So bring down the 5. 5 times 4 is 20. 20 minus 18 is 2. 2 times 4 is 8. Negative 11 plus 8 is negative 3. And negative 3 times 4 is negative 12. And the remainder is 0. So the quotient is 5x squared plus 2x minus 3. And all they want you to do here is use synthetic division to divide. So that's the answer right there. Alright, so 43 is a 4-term polynomial, a cubic. It does not factor by grouping. If you do the little box, or if you pair them up and try to do factor by grouping, it does not work. So we have to do the P over Q method, okay, and find the zeros this way, if they exist, if it has any rational zeros. So I went ahead and I found all the factors of the constant of negative 4 right here, and so here's a list, and then all the factors of the leading coefficient, which is positive 4, and they're right here. So now we're going to do P over Q. So I'm going to take the 1 and put it over each one of these 3. Then I'm going to take the 2 and put it over each one of these 3, and then I'll do that same thing with the 4. Put it over each one of these things, of these numbers. So I have 1 over 1, then 1 over 2, then 1 over 4. Then 2 over 1. 2 over 2 is already there, 1. And 2 over 4 is already on the list, 1/2. Okay, then I go on to the 4. 4 over 1. 4 over 2 is already there, it's 2. And 4 over 4 is already there, it's 1. So here's my list of possible rational zeros. So I'll start with 1. And again, remember we do synthetic division. So 4, negative 20, 17, negative 4. Bring down the 4, negative 16, 1, and it's not going to work right. Let me try 1/2. Same thing, negative 20, 17, negative 4. Bring down the 4. Half of 4 is 2. and then negative 18. Half of negative 18 is negative 9, and then I get 12. Half of negative, sorry, not 12, sorry, take it back, 8. Half of 8 is 4, and then that's 0. So I found a 0 right there. So the 3 remaining numbers here, because remember this is a remainder, so these 3 numbers right here are the coefficients of the polynomial that's the other factor, right? So this is going to be 4x squared minus 18x plus 8. I can factor out a 2 to make the number smaller. I can do that. I'm going to factor out a 2. And then I'm going to do this, 8x squared. Factors of 8 that add up to negative 9 are negative 8x and negative x. And then I'm going to do the little box, or you could do the x factor, whatever you'd like. So 2x squared, negative 8x, negative x, and 4. So here, the first row, I can factor out a 2x. Then x, negative 4, and negative 1, and that works. So the factors are 2x minus 1 and x minus 4. So the zeros, well, I already had a 0 from the top, this one up here, 1/2. And then this one also gives me 1/2. So the multiplicity of the 1/2 is 2, right? It's even. So I don't have to write it again. And then for this one, x minus 4, it's 4. So here are the zeros. Alright, so 44, I found the factors of p, or the p factors, which are the factors of negative 25. So plus or minus 1, 5, and 25. Then the factors of 2, which are the q factors, which is plus or minus 1 and 2. I made the list of p over q over here, and I took this one and put it over 1 and put it over 2, and that's how I got these two. I took the 5 and I put it over 1 and over 2, and that's how I got these two. Then I got the 25 and I put it over 1 and over 2, and that's how I got these two. Okay, so this makes up the list of all the possible rational zeros for this polynomial. Now notice I set up the synthetic division a little bit different than in the other one. My list is kind of long, and I don't know how long I'm going to have to go before I find a 0. So when that's the case, you might want to set it up like this, so you're not writing the leading coefficients over and over and over again. So these are still the leading coefficients, right? All of these for the polynomial. And here's the first one I'm going to try. I'm going to try 1. And why? Just because it's the first on my list. So you bring down the negative 2. Just like if you set it up this way, there's a little bit some mental math that you have to do. You know, with the other setup, you write everything down. But on this one, you do something in your head. So I'll tell you, you'll see as we go through this. So we brought down the 2, and so negative 2 times 1 is negative 2. And this is what you do in your head. You say negative 2 minus 1, that's negative 3, and that's what you put right here. And then negative 3 times 1 is negative 3. You add that, you combine that with 51. You do that in your head. So 51 minus 3 is going to be 48. Okay? And then 48 times 1 is 48. Then in your head, in your mind, you add it to 25. So 48 plus 25, that's going to give you, what, 73? Already I can tell it's not going to work because the numbers are getting bigger and bigger. And not, I need to get a positive 25 so I can add it to negative 25 to get a 0, and it's not going to work. So 73 minus 25, not 0. Okay, so you can stop right here. Then I'll write down the 1/2. You bring down the negative 2. Okay, so we saw that this line did not work. And so negative 2 times a half, or half of negative 2 is negative 1. We combine it with a negative 1 up here, so negative 1 and negative 1 is negative 2. And then half of negative 2 is negative 1. We combine it with the 51, that gives us 50. Half of 50 is 25. Okay, so 25 plus 25, because we're adding it to this 25 right here, that gives us 50 again. And then half of 50 is 25. 25 minus 25, and y minus, because this is negative, is 0. So this one worked. Okay. So for the next rows, I'm not going to use the original numbers anymore, because remember, we already, by getting a 0 right here, we got a reduced polynomial right here. So this is the one I'm going to use now. So I'm going to draw a line underneath this one and go to the next number. I'll try 5. Okay. Bring down this 2 right here, or negative 2. So 5 times negative 2 is negative 10. Negative 10 minus 2 is negative 12. 5 times negative 12 is negative, 60? So I'm multiplying this times this, I get negative 60, and then in your head you add it to positive 50, so that gives you negative 10. And then 5 times negative 10 is negative 50. Negative 50 plus 50 here, that's another 0. So that one worked out. So that's another 0 right there. Okay? So now you have two choices. You could continue with synthetic division, but there's a lot of numbers to choose from, right? And once you have 3 here, that's a quadratic. So you can just factor by, quadratic formula or factoring, like the x factor or the box method. So I'm going to go ahead and do that instead. So negative 2x squared minus 12x minus 10. I'm going to factor out a negative 2. See, it's a lot easier to factor it this way, see? Because factors of 5 that add up to 6 are 5 and 1. So it's x plus 1, oops, and then times x plus 5. So that gives me the other two zeros. So the complete list of zeros is 1/2, 5, negative 1, and negative 5. Okay, we're being asked to simplify and write it in standard form, the a plus bi form. So first off, this here is 5i. The square root of 25 is 5. The square root of negative 1 is I. And then I'm going to distribute the negative. So now I'm going to combine the real part, which is 5 and 3, and then the imaginary part, which is negative 5 and negative 2. That's it. For 46, I'm going to use distributive property first. So 1 times 9, 9. 1 times negative 8i, negative 8i. I times 9, 9i. And I times negative 8i is negative 8i squared. Now I squared is negative 1. And you have a negative 1 times a negative 8. So this term right here becomes plus 8. So 9 plus 8 is 17, and then these two combine to give you positive I. So for 47, they want you to find the complex conjugate of this number and then multiply the numbers together. So the complex conjugate is negative 14. That sign does not change. Okay, that stays the same. What changes is the sign in the middle, in between. So right here, it's negative or minus square root of 13i. And we're going to do distributive property. So negative 14 times negative 14 is 196. And then plus 14 radical 13i, and then minus 14 radical 13i, and then minus square root of 169 I squared. Okay? And as you can see, the two middle terms right here, these cancel out, and that's what a conjugate is supposed to do. You're supposed to get rid of the two middle terms. If you don't, then your conjugate is wrong. Okay, now here I've got 13, and here I got negative 1, and there's a negative there already. So negative times a negative right here is a positive. So I end up with 196 plus 13. So the answer is 209.